Hi, Safe.
Hi. Hello. Hi, Diego.
Nice to see you here.
Likewise, it's nice that I've checked my email. There is 1 hour difference now between the UK and I mean.
Good morning to you all. I'm Franco Di Persio. I will be co-moderator together with Aris.
Hello.
Hi, Aris Di Meas. Yes. So Aris, we let a bit 1 minute more to let people in.
Yes.
Yes.
Great.
Okay. Okay. Well, more people coming, but so maybe we can start, Aris. What do you think?
Yes, I think so.
Okay. So first of all, welcome to you all to this parallel session 1 on the Decarbonizing EU Islands. Will be me, Franco Di Persio, and Aris Di Meas moderating the session. So let me first introduce the speakers in this parallel session. We will have presenting from 4 different projects focusing on the issue of decarbonizing islands. So we'll have from the project REACT, Josep Mitas Carmona from Veolia. I will make a short introduction of them. So Josep has a degree in building engineering and a degree in energy engineering from the University of Catalonia in Spain. He has experience in building engineering and real estate management. Now he's working in the Veolia Group since 2 years, focusing on technical and financial assessment, design, operation, management of several R&I projects. And coordinating and participating in several projects Horizon 2020. Then we will have a presentation from Kostas Kominos, he works in Daphne, General Manager in Daphne. He will present on the project called Kythnos Smart Island. He's a general manager, as I was saying, of the Daphne Network of Sustainable Greek Islands, which is an association of 55 Greek local and regional government providing assistance, technical assistance, and to enable the transition for a sustainable and circular economy. He's also vice president and of the Smart Sustainable Islands in Federarene, which is the European Federation of Agency and Region for Energy and Environment. And of course, he has significant experience in clean energy and local development project, especially in the Greek and European island, which has been working in the last decade. Then we will go to Diego Pisera from Algo VAT, Italian company. So he will present on the project called VPP for Islands. Okay, I don't have very much information on Diego Pisera. So he's a PhD student, if I'm not wrong. But Diego, please correct me if I'm not correct.
Yes, correct. I'm a industrial PhD student, so I'm having a PhD in the University of Genoa, and in the meantime, I'm doing research in the field of energy, clean energy, in Algovat. That is a green tech solution provider.
Right, very great. Thank you, Diego. Okay, then we will finish our session, our round of presentation with Alessandra Montanelli from Sinloc, which she will present on NESOI. She is Alessandra Montanelli, a coordinator of the EU Island Facility project, NESOI, and she is an economic finance advisor with experience in the energy transition sector since 2019 is part of the core team of this project. So okay, so that will be the let's say the four project we will speak about. After all, we will have so it will be a 99-second pitch. So that means a very short presentation from all of them, and will be moderated by Aris, this part, and will follow then a panel discussion with the presenters, and also, we will, of course, look at the chat. So please, if you have any questions, to the panelist, please write down in the chat. And if it doesn't work, we will also look at. if you please raise your hand on Teams, and then we will give you the word. And also, we will have. Some Slido, so some questions on this along this parallel session, and so probably that is the best time now to start the first Slidos. So now I assume, yes, great. Okay, so that is the Slido, and then the first question. It will so that will be really useful for us to understand what is the group of people assisting at this session, from where they are. So the first question is in which country your company organization is located. So it will give us a nice feedback on the people that are assisting in this session. So if I'm not wrong, we are 19 in this session. Okay, so 4 people answered, 5 now. So Greece is quite predominant. But okay, there is also Italy, Spain, Portugal. Yeah, that is obvious. There is a lot of Cyprus itself is an island, so of course all the European countries that have islands in their territory, of course. Spain, indeed. Okay. Yeah, that is obvious result, but okay, interesting to see. Then probably we can go to the next question and to look at which sector are you from. So, okay, so as we see also in the In the introductory section, probably we are just reflecting what wasn't there. So there is a lot from, okay, interesting. So there is a research institute indeed, but there is also a lot of DSO, technology provider, university as well. Okay, good. Interesting result. Maybe scrolling down if there is other, probably not. Okay, national platform as well. Good. So there are things interesting. The DSO, Research Institute, University are more or less, we are represented here in the same percentage. Okay, good, interesting. So indeed, people that will be interested a lot in this, in the decarbonization of islands that are really probably the most critical part in our grid system. Then it probably is the best place to start to look at the resilience and security of the system. Okay, so now probably we can start. We'll pass the stage to Aris.
Okay.
Timeas for start the 99-second pitch and the presentation.
Okay. Thank you, Franco. I would like also to welcome you all here, and I hope we will have an interesting workshop. So now we are going to the next phase of this workshop. It's the 99-second pitch. Namely, each project representative will make a short presentation to learn about the projects and the challenges. So we will start with the REACT project, and Joseph Mitats-Carmona will make a presentation. Yeah.
Good morning. Can you hear me?
Yes.
Perfect.
Adeola, we are going to see the slides.
Is it me, Aris, or I thought you will be sharing all our presentations? I can share it as well, so it would be no issue.
Let me share my screen. What's this?
Okay, perfect. Thank you. Thank you, Aris. Well, I'll try to be as brief as possible. REACT, as you can see here, stands for, or is the acronym for Renewable Energy for Self-Sustainable Island Communities. We are a 4.5 innovation action research project funded under the European Union's Horizon 2020 program. Our consortium is comprised of 25 partners from 11 European countries, and our work started back in January 2019. REACT's integrated package, we have hardware and software deployments here, will be piloted on 3 demo islands to validate the technical and financial feasibility. Those islands are La Graciosa in the Canary Islands in Spain, San Pietro in Sardinia in Italy, and Inismore in the Aran Islands of Ireland. And REACT also plans on delivering a scale-up and large-scale replication solution available for what we call 5 follower islands, which are much bigger islands where to deploy these energy systems. Our challenges are mainly related to the traditional electrical energy grid models that are facing the islands, which are mainly related to energy cost overruns, lack of strong energy supply infrastructure, and variable load profiles. And well, we have the objectives of maximal exploitation of renewable energy sources, and we want to deploy several technologies. In that case, as you can see here on the left picture, the REACT works around 4 innovation levels. We want to deploy innovative technologies such as high efficiency PV systems, power to hydrogen storage, battery energy storage systems, EV chargers, and air source heat pumps. All of them integrated through what we want to deploy, as you can see on the right picture, on a cloud-based platform, which is compliant with several smart grid interoperability, automation, and interfacing standards. We want to enable synergies among different grids, electrical, heating and cooling, transport, water, and waste treatment grids. And we want to foster user engagement and new business models. And we expect the REACT solution to have significant impact on geographical islands energy ecosystem, providing several benefits, as you can see here, in terms of energy savings and increased energy efficiency, energy cost savings, and other technical and economical and environmental impacts. Thank you. If you have further questions or queries, you can contact me whenever you want to. Thank you. Aris, you're muted.
Yes, sorry. So next project is Kythnos Smart Island, and Kostas will present this project. Kostas?
Thank you, Aris, and thank you for the invitation to you and for ETIP SNET for participating in this webinar. So I will be quick. You're sharing the slides, right? So we go to the next one.
No, I don't have your slides here. Adeola, do you have the slides of Kostas?
I can share if you want.
Yeah, please do so.
So I actually just lost 1/3 of my time, but so yeah, you can see my screen, right, Aris?
Yes.
Okay. So Kythnos, well, I suppose that you are familiar with the island. Actually, just arrived in Kythnos half an hour ago, and I'm sitting next to the port. So apologies for maybe for the not perfect conditions. Kythnos has been a test bed for energy technologies on islands for several years, and you can see a timeline on the left side of this very condensed presentation slide, trying to reach the number of slides for this presentation. But it started back in the 80s with the first installation of a wind park in Europe. And actually, for several years, there have been additional infrastructure like PV stations combined with batteries, and actually around 2000 managing to cover the majority, let's say, of the load on the island, especially in wintertime, through renewables, a combination of wind turbine, PVs, and small batteries. The system actually went into decay around the first decade of 2010, and currently, jointly with the Technical University of Athens, we are reviving, let's say, Kythnos through the Kythnos Smart Island as a living lab again for energy interventions. On the right side of the slide, you can see some specificities for the island. It is a small island nearby Attica, nearby Athens, with 1,600 inhabitants, non-connected, with a peak demand around 3 megawatt during the summer season, and with an installed thermal station on the island using as a fuel diesel. It has a significant cost for producing electricity, and there is a small amount of renewables installed on the island. Actually, what we are trying now to do, following up this rich, let's say, history of Kythnos, is to go into more integrated, let's say, interventions for the island, combining clean energy production with water management, waste management, mobility, and transportation, providing, let's say, a new vision for local economic development for the island. And here you can see the different interventions. So we're actually working towards an integrated, holistic approach for the island. Using energy in a non-connected island to also provide green energy for transportation through EV charging, using waste management, actually to produce electricity locally through the exploitation of bio-waste. We're actually trying to increase the energy efficiency, energy upgrade all municipal buildings, but also going into NZEP buildings for the private sector and tourism. We try to minimize or optimize actually the use of energy for water production, water management, and of course, most important, work towards a smart grid transition of the current distribution grid on the island to manage all this kind of loads and installations. So this is in as short as possible presentation of the KSI project, and more than happy to reply to any questions following. Thank you.
Thank you, Kostas. Now we can proceed with next project. Let me share my screen. So can you see my screen now?
Yes, we can.
Okay, we can move to the next one, VPP for Islands, and Diego Pissera, the floor is yours.
Okay, thank you, ETIP SNET for this opportunity to present VPP for Island in this workshop. Next slide, please. So VPP for Island means Virtual Power Plant for Interoperable and Smart Islands. It's an innovation action research project funded the Horizon 2020 program as a consortium with 18 partners that represent 8 countries. It's starting in October 2020. The project coordinator is Université de Marseille, and in the project are involved 5 islands, 5 demonstration pilots. The 2 lead islands are Gökçeada, an island located on the northeast of Turkey. The other island is Formentera, the other leading island. The 3 following islands are Grado in Italy, Bornholm in Denmark, and Botjada, another island in Turkey. So we have island from north to south, from east to west. And the objective of VPP for Island is to facilitate the integration of renewable system, accelerate the transition towards smart and green islands, and exploit the efficiency of potential and innovative storage approaches. Next slide, please. So to reach this goal, in VPP for Island project, we will develop a disruptive solution that will, let me say, revolutionize the existing virtual power plant. So it will be basically a virtual power plant that integrate a digital twin concept. So will be a digital version of the island. It will integrate a virtual energy storage system to combine flexible load and energy storage system, and distributed ledger technology. So smart contract based on blockchain to allow to member of smart energy communities, for example, or citizen energy communities, to have peer-to-peer energy transaction through blockchain. The goals, let me say, the overall goals of the project are that one, to provide a technology that is able to facilitate aggregation and smart management of distributed energy resources along the islands, increase the flexibility and the profitability of the whole energy system of an island, give the possibility to valorize the demand response from demand side, let me say, and promoting self-consumption with the mean of energy communities. Thank you.
Welcome. So last project is Mesoi, and will be presented by Alessandra Montanelli.
Thank you. Thank you for the introduction. So I think we could start. I will introduce the European Island Facility NESOI, which is an Horizon 2020 project kicked off in October 2019. NESOI is a technical assistance platform, and we support European islands' energy transition processes, facilitating the decentralization of energy system, contributing also to European policies in achieving 2030 targets. As I mentioned, NESOI deploys technical assistance activities, supporting feasible projects towards their implementation and facilitating access to finance. We are already supporting more than 40 islands, and we target to have 60 on board after the second call, which is now open. Selected islands are benefiting from tailored technical assistance provided directly by NESOI professionals, but also complemented by local contractors financed with our grant resources. So as a whole, beneficiaries are being provided with more than 6 million euro of resources and activities, and they can also benefit from our digital platform, capacity building events, and also training. Next slide, please. Yes, so this is the results we achieved so far. We're very proud of this. Last year we had our first call for proposals and more than 100 applications were submitted. We were able to finance 28 initiatives and we also created a reserve list from which we're now activating additional 40 projects. So we are having 30 initiatives ongoing, located in 50 islands, in 11 different countries. So actually the expectations are very high. These initiatives could trigger more than €1 billion of investments with an allocated funds of approximately 2 million. So the leverage factor is pretty high. So yes, these are just preliminary results. As I mentioned, we have a second call ongoing to select additional initiatives. So even if the process is pretty complex and ongoing, we are very satisfied and this is only the beginning. So thank you.
Welcome. Before proceeding to the next part of our panel, let me remind you about the Slido, and we can have next question. Yes, Teola. So next question is how important is the decarbonization of EU islands? So everyone agrees about this one. It's very, very important. Okay. I think almost everyone answered this question. Can we go to the next one? So the question is, what are the main technical barriers to increase renewable penetration in the islands? Okay. Regulatory issues. Okay, can we go to the last question? Anyway, I think we could proceed with the discussion. So we have prepared some questions and Franco will proceed with the first question.
Okay, thank you, Aris. Thank you also to the panelists for the very short but good presentations. So let's go for the questions and to start, let's say, the discussion, the panel discussion. So let me retrieve the question first. Sorry about that. Just a moment. So the panel discussion. Okay, so was very interesting to hear from you, you that you are in really dealing with those projects, to see the achievement, the objective, and the result of your project. But I would like to ask, what are the main achievements of your project? So what is really the core result of your project? What really you appreciate most as a result of the project you are working in? So probably we can start from the first, so from Joseph with the project React. So can you give us some indication?
Yeah, sure. Thank you, Franco. And again, thank you for inviting us to this workshop. Yes, since we are a little bit more than besides or beyond half of our project, we are finalizing the deployment activities, meaning that all technology assets are currently being deployed in all the islands. I believe that one of the biggest challenges that we were facing is kind of already been shown and seen on our questions on Slido, meaning that we have dealt with strong regulations. We are dealing with protected environments, mainly on these very small islands we are dealing with in the React project, but we are confident that we can overcome all these barriers and provide some lessons learned, both to the European Commission and to the local authorities, so that the implementation and deployment of renewable energy infrastructures can be eased, because this is something that we have been very difficult to overcome during our last months. And again, what we expect or what we believe is a very valuable impact or expected outcome of our project is being able to integrate those many different manufacturer technology into one single cloud-based platform that integrates all these assets and will allow us to manage and control the different demand response actions, so that we can increase the energy efficiency and the energy cost savings of our end users. So again, I believe that this is a quite important achievement to overcome these barriers and to being able to implement this energy infrastructure on small islands. And we believe that the regulations should be eased to allow this kind of implementations on other islands.
Okay, thank you, Joseph. Because you mentioned during the presentation the challenge was the modeling of the energy system. So that's you means really to integrate all the components is
yes.
Challenging.
And to forecast both the demand and the generation, which is something that the Austrian Institute of Technology, which is one of the main technology representatives of our consortium, is dealing with. They are kind of providing very interesting algorithms to quietly accurate the forecasting generation and demand of the buildings according to historical data and to their own deployed technology there. So yes, we're aiming to perform this optimized control through forecasting and other analytical services of this cloud-based platform. So that would be a very valuable outcome of our project, and we're confident that we will be able to do it.
Okay, good. Thank you. Great, Joseph. So probably we can then share again the questions and to go to for another project to Costas for the Kythnos Smart Island. So the questions, Costas, I don't know if you can see. Yes, he's here. So what is the main achievement, main technical regulatory barrier, challenges, and okay, that is also another question that I didn't stress out before. Sorry about that. So what is the potential synergies with other energy carrier, energy storage technology in your project? So please, Costas. tell us?
Thank you, Franco, for the questions. Yeah, actually, our project is at the final phase of deployment, and which includes different interventions in the sectors, mainly on the demand side. But one of the main achievements right now is that we have it's actually a non-technical, I would say, achievement, but it's one of the most important elements to manage to enable the clean energy transition and decarbonization of Ireland. It's actually maintaining the very good collaboration and the trust and support by the local society. So we have actually started with realizing small interventions in a participatory way, like changing, let's say, luminaires, conventional luminaires with lamps for the street lighting, with LED ones, increasing the energy efficiency and reducing the energy consumption of this load. We have also started the installation of EV charging stations, and actually combining the installation of the chargers with overall, let's say, upgrades in terms of aesthetics of the areas where the installations were made. We have carried out several meetings with the locals and discussing the different interventions, and this has actually formulating an enabling framework for the interventions to come. And I would say that this is an element that we all have to keep in mind when it comes to projects in small societies and small islands, that usually locals and are, they always have a second thought of what we actually want to implement when it comes to innovative and renewable energy technologies. When it comes to technical and regulatory barriers, taking into account that Kythnos is a non-connected island, there are specific, let's say, provisions in the regulation when it comes to the operation of the systems, and this poses limitations in the number, in the amount, let's say, in the capacity of renewables, intermediate renewables we can integrate in the system. And this is something that we are, and this very often, results in curtailments of wind parks and the maximum, let's say, upper level, upper boundary of renewables we integrate in the system. Nonetheless, we could combine that with specific loads and have a more flexible, let's say, operation of these renewables. When it comes to overall challenges, I would say that this has to do mainly with actually engaging the municipality and the locals, and this is one, as I said before, one of the challenges that we have currently overcome, that we have managed to go hand by hand and work with them. And this is, again, one of the key issues here is synergies. So when we talk about energy, we talk about synergies with water, with waste, with transportation. So we're solving, let's say, problems we have to do with desalination, with managing bio-waste on the island, which causes environmental impacts on the island. So we try to produce biogas from the livestock management on the island and from the waste produced. So this creates, let's say, an environment that is more collaborative and synergetic with the society, and this is also beneficial for the system, because when we have a desalination plant, this is a significant load, especially for the winter time for the island. If we manage to electrify the majority of the transportation of the island, again, we have flexible loads that can be combined with renewables, and also with a smart grid facilities and an energy control center can enable the further and the maximization of the decarbonization of the island. So for doing so, we are working very much with this kind of synergies and bringing a holistic approach in our interventions. Thank you, Franco.
Thank you. Thank you, Kostas. Very, very good representation of challenges and result of your project. I was triggered by what you said about the involving the local, so the societal approach of your project. So how can you give, let's say, a hint? How do you gain the locals to follow the indication of your project? What was the main, let's say, reason for them to join the changes that you propose?
Well, Franco, I would say that this has been a long process, and we've been working with the island for several years. But actually, as I presented in the first slide of my presentation, we try to integrate the technological innovation in a further, let's say, in a broader innovative development, local development approach. So we are actually working with the island on different fields. Either we do it, either you do it on yourself, like our association, Daphne. We work in a very interdisciplinary way, so we can work like with sustainable tourism, which is very important for the locals to provide new solutions that can provide new income, or even open, let's say, the touristic period that can provide more people on the island. And this is very, the locals are happy with that. So we need to work replying to the questions that the locals are raising in priority. And they don't raise a question about energy or decarbonization. They raise the question about the frequency of their transportation with the mainland. They raise questions about water sufficiency and water quality. They raise questions about the waste collection and having a very clean island for the visitors. So we try to work in an integrated way. Either you do it on yourself as an entity, or you do it in collaboration with others. But islands and the rural areas, I would say, they need more integrated strategies and solutions. This is the way that we have proceeded. We have already realized projects on other fields that they have created a very good image for us, for the locals. So when we come and we discuss about demand response or flexibility or electromobility, etc., they say, okay, this sounds quite exotic, but okay, we know these guys, they are doing a good work, so probably they are not bullshitting us, and there will be something interesting for us too. So that is the approach we have followed.
Okay, good to know. Probably an example to follow for several projects. So to interact with the locals before, in advance. Otherwise, you can maybe face resistances that is not good for anybody. Very good. So let me switch to the other project, to Diego Picera for the VPP for Islands. So Diego, so let's see. You see the questions in Teams. So can you provide us an overview based on those questions, please?
Okay, related to the achievement, I think that the best achievement of the project will be that one of building a digital twin, cause data. I mean, as someone said in the introduction session, data are really important in this case of study, because will make us sure that the investment that we are going to propose in the highland will have a return and a good impact for locals mainly. I can imagine, for example, business model of renewable energy communities or transportation, and so have a good historical data about the consumption, the production from wind turbine, for example, and so on. Make the business model and the calculation of return of investment, for example, easier, and will be easier also when you propose this kind of new and exotic, let me say, as energy communities for some local action, be more. It's easier with good data. Build a good strategy and propose a new action. The second question about regulation barriers. We work about integration of storage in this island, and we realized that it's super hard to find a good, a profitable business model for storage, because the cost is still quite high. So for make storage profitable, we should provide also global and local ancillary services. So global services related to frequency regulation, local ancillary services related to services that storage and flexibility in general could provide to DSO. And let me say, it's almost impossible in some European countries at the moment provide ancillary services through distributed energy resource. Through aggregation of this kind of distributed resource. I think that it will be an important slice of a business model of a storage in an island, let me say. So these barriers, it's make hardest have an investment in on storage in islands, but in mainland as well. So this kind of barrier are let me say regulation barrier on ancillary services are one of the main barriers that we face today. Related to technological barriers, let me say there are not a lot of technological barriers because it's quite mature, the technology, let me say. But one of the main problem is the availability of this kind of digital system. Let me explain better. We can lose a package of data. We cannot lose a package of energy. So match this kind of these two different words is not easy, and this is the main technological barrier for me and for, let me say, for the system. And about the synergy with other carriers, we are investigating the synergy between hydrogen and mainly between fuel cell and the battery energy storage system in order to provide flexibility with a lower levelized cost of energy. So we are investigating the synergy between these two vectors. And that's all for my own.
Thank you, Diego. Yeah, nice overview, interesting overview. I was a bit wondering about this technical barrier that you mentioned, the data and energy mismatch. So what is the reason of this mismatch? So why is so difficult to aggregate those two entities, data and energy?
Yeah, as I said, the main uncompatibility is that the word of data could have a fail, easy fail. In other case, the word of energy could not have a fail, or let me say, if you have a fail in the word of energy, one line go down or something, let me say, of big happens. In the word of data, you can miss a package without nothing gonna happen, let me say. And when you deal with the virtual power plant, you have to coordinate hundreds of distributed energy resource. Missing some data could raise some big problem for the energy system, cause these incompatibilities of missing a package, as I said before, and this is raise two kind of problem. If you miss a package of data, cause that's the word of ICT, let me say, of if you miss a package of data cause cybersecurity. So there is with this, when you try to match this kind of new word, a new problem burn is that is cybersecurity. So this is the main challenge, let me say, in that we are facing now in this moment, matching these two kind of word that in the past, let me say, in the last 2 decades was quite different, and now they are linked more than ever, and in the future the transition will happen thanks, let me say, of the link of these two different words plus the word of transport, electric transport. So the interface and matching in the right way this kind of word with different priorities and different, let me say, processes, it's the real technological challenge in this moment.
Yeah, I can imagine. So, but the artificial intelligence can work in this case?
For sure. Can work for have some plan B in case, for example, in case some data is missing. Can work for avoid and detect cyber attack. Can work for have a better optimization based on forecasting. These are the three words where artificial intelligence could act to facilitate, in my point of view, this integration between these two words, ICT and energy.
Okay, great. Thank you, Diego.
Shall I make a couple of questions? Yeah.
Yes, sure.
So, in the beginning, you mentioned application of digital twins. Can you explain more, because it's a concept that we hear many times, and I think many people do not fully understand.
Okay, let's be from that's the first vision of digital twin. Let me explain. For an electrical engineer, mainly a digital twin of a grid is the representation of node and lines, and the representation of what is happening in these nodes related to voltage level, and what is happening in the lines related to currents level. But for example, for civil engineer, for maintenance engineer, and so on, the digital twin is the 3D representation of the grid and the 3D representation of the generators and the loads, for example. But we have another level of digital twin that are the results of digital twin. So if you link the data that you have from node lines, the data that we have from the graphical representation of the state of maintenance, for example, of the asset, and with artificial intelligence, you have another level that is the knowledge that this data could create if linked with artificial intelligence. So we have another aspect that it's the, as I said, the knowledge created by the digital twin. So in my point of view, the digital twin at the moment is built by three main concepts. The first is representation of the state of the asset, so a 3D graphical interface, and so on. A second aspect of digital twin and from electric grids are the representation, mathematical representation, I speak about nodes and lines, and the measurement that the digital twin could receive from the field about tension and currents. And the third aspect is what artificial intelligence could extrapolate from this data that I listed before, data related to 3D and lines and nodes. So this is the digital twin in my point of view, and let us say also in what we are developing in WPP for Island. So as I said, the main aspects are data that you read, data that you collect, data that you produce through artificial intelligence.
Okay, and my second question is about storage. You mentioned that it's still expensive. The demonstration sites you have are interconnected or isolated systems?
All the demonstration sites that we have are interconnected.
Okay. Because if it's not, if it's an isolated system running on light or heavy diesel, then the cost of
It's higher.
storage is not that high.
No, because the cost of energy traditionally in that system that get energy from diesel, it's higher. The levelized cost of energy. Yeah.
Okay, that's all from my side, Franco.
Yeah, thank you, Aris. Thank you, Diego. Okay, so now let's go to the project NESOI, and Alessandra. Please give us your view on those questions.
Thank you. Yes. So as I mentioned in my introduction, actually NESOI is a pretty peculiar project since we're not deploying any specific technology, but we are providing advisory services and grant funding to support projects in their development phase, so right before the implementation. As indeed our main objective is to turn transition plans into projects, into investments. And indeed, our target is to trigger investments, so to activate finance and to help islands in their processes. So to do so, our main challenge was to develop some kind of concrete support. So what we did is to design a combined approach to provide islands with. Can you hear me? Oh, yes. Okay. So to combine.
Yes, we can.
Thank you. It said, yes, this combined approach, the merging of both the experiences from the partner of the consortium, which is actually made of 10 very experienced companies all over Europe, but also with the local knowledge, since locals have, of course, many competencies, also in relations with the local environment, so the criticalities, but also the opportunities. So when it comes to the main achievement, as I mentioned, we are very proud so far of the results we got from the very first round of projects. We had more than 100 applications. So this means that actually the interest from the islands is very high, that the decarbonization is actually an issue, and islands are willing to complete their paths towards energy transition. So concerning the barriers, well, from a technical point of view, from our experiences, even if projects are still ongoing, I would like to mention project fragmentation. So islands are suffering from this probably more than the mainland, and this is also linked with low unitary costs for intervention, which leads to difficulties in reaching, for example, the adequate critical mass for investments. And also, if we think of small islands, there is an issue on the infrastructure. So often there is a poor infrastructure concerning, for example, the grid. So when it comes to, for example, RES penetration, this could be an issue. And also, this can also be applicable, for example, in other infrastructure in general. So, for example, roads. So in many islands, we are dealing with this kind of criticalities. Then concerning the regulatory barriers, well, sometimes we're facing very complex frameworks, for example, concerning the permitting procedures that sometimes are more complex than on the mainland, for example, due to, I don't know, protected areas, for example. And also there is the absence of simplified permitting procedures for small-scale plants and in general projects. And finally, let me mention also the uncertainty, which is linked with the current evolving framework on, for example, energy communities, which is also another issue we're facing, for example, in Italy, but also in Croatia. So this is kind of having an impact also on our activities, since there are still a lot of gray areas and we need to have some confirmation also from the regulatory point of view.
Okay, thank you, Alessandra. I listened to you, and then I heard a word that is not familiar really to me. The project you said fermentation, something like this. What is the right word?
Maybe implementation.
Implementation. Okay, yeah. Sorry. Okay,
maybe
that's clear. Yeah, sorry. Okay, so probably you said that the islands suffer from because they are local.
Fragmentation. Ah, you mean fragmentation? Yes.
Fragmentation. Okay. So that's it. Make more sense. Okay, because low cost, low unitary cost for intervention, and being detached from the decisional, let's say, centers can be a bit more tricky, of course. But have you found some, let's say, some regional in some nation are a bit more, some region, some nation are a bit more autonomous? Have you found differences if there is more autonomous, let's say, regulatory freedom with respect to some issue like protection of areas can be implemented at regional level? So probably the decision level is not very far.
Yeah, indeed, actually, we are dealing with a lot of also differences because our projects are spread all over Europe. So actually, also national frameworks are different. So we need to take this into proper consideration. And for this reason, we have this combined approach, which is, according to us, a very winning approach. So local knowledge can supplement on this. So yes, as you mentioned, actually the regulation is also a matter of regional level. So yeah, actually we cannot operate at this level. We just need to take the framework as it is. But what is important here is to mention the European level, which is very often affecting and impacting on the national levels. So the European directives needs to be translated in the national frameworks. And this is, I think this is one of the main barriers from the regulatory point of view at now, at least.
Okay, thank you, Alessandra. Have you question for Alessandra, Aris?
Yes, I have one.
Yes.
Kostas mentioned in when he was answering these questions that is important to involve local communities and talk with people and persuade them and somehow make them involved in this project. What do you do for this aspect? Do you consider in the planning of projects?
Yes, absolutely. We are dealing with this in particular with projects which are at what we call an early stage, meaning in their planning process. So it's very important to have the community on board to also share with them the direction, the ambitions for the transition. So yes, we are dealing with this. We are having local advisors in particular dealing with this. And this is an issue which should be taken, of course, in adequate consideration. So yes, we also have some experiences where local community were not involved, and this leads to some criticalities afterwards. So for sure, it needs to be taken into consideration.
Okay, thank you. That's all from my side, Franco.
Okay, so let's check now the time. So 11:45 to 12. So we will be here in this session. Correct me if I'm wrong, Aris, but until to 10 past 12, correct?
Yes.
Okay, so let me check now what is the so the panel discussion. Basically, okay, we have more time to keep discussing with the panelists. So let's give also a look at the chat if there are some question in the chat. Okay, so I have here. Okay. So from Azzopardi, Brian, we have a anyone interested in joining us on 2 twinning project action, NEMO, School 2 and Jump to Excel Day conference and School 3. Okay, I don't know if it look like a project, probably I hopefully related with this island decarbonization. Is Anzo Pardi, Brian, listening? If you want to explain.
Yes, yes. Can you hear me?
Yes, sure.
Yes, so both projects are related with the topics which we are discussing here. One is related with electric mobility, and the other one is related with the integration of photovoltaics, mostly on islands. So it's very related to the topics here. And yeah, if people who are participating here wants to join us, there are the links there available, and we have especially actions like the schools that are open to everyone, and we also can support travel within the European project framework.
Okay, thank you, Brian. So here is in the chat for everyone who is interested. Okay, so let's we can, Aris, go a bit deeper than in the discussion, and maybe we can.
Yeah.
Okay, we have also a question from Matthias. Sorry for the pronunciation. Pantelli.
No
Yeah.
problem.
Okay. Yeah.
Thank
Matthias,
you very much.
yeah,
Yeah,
tell
thank
us.
you. And
Yeah,
hello
welcome.
from Cyprus. I'm Matthias Panteli. I'm an assistant professor at the University of Cyprus. This is a very timely workshop. It was a pleasure to be here because actually tomorrow we'll have a big debate on the climate energy plan of Cyprus, and everything you discussed is very relevant to the debate we're having tomorrow. So my question has to do with scalability issues. I noticed that most of the cases that were presented in the very fascinating projects today are a bit of smaller scale on Cyprus as an island. And in Cyprus, when we're going to be discussing all the very fundamental issues that were discussed today, from acceptance and participation of the people to regulatory, to aggregation, coordination of different resources, so on, the problem becomes much more complex. And I'm wondering if the panelists have any experiences to share potentially from the projects that they were involved with, let's say, bigger systems and bigger islands. Compared to the size of Cyprus, perhaps with Malta, or I saw Brian on the line, and dear colleague and friend from Malta, or Crete, for example, from Greece, and so on. Something, let's say, which is bigger than smaller islands that were described. Thank you.
So please, from the panelists, feel free to answer.
Hello, it's Giuseppe Mitats here from Veolia. Can you hear me?
Yes, sure.
Yes. Okay, perfect. Yeah. Thank you, Matthias, for the question. Yeah, in fact, from our case, we are just deploying, as you were saying, kind of a small scale scenarios on the demo island, since we are dealing, for example, in the React project with 3 islands, which, for example, in La Graciosa or in Ainos More, we are speaking of roughly 1,000 inhabitants. But for example, for San Pietro, we are already dealing with a scenario of more than 10,000 people living there. So that would be quite of a bigger scenario. But we are planning on exporting and scaling our technology solutions to, for example, Polo islands such as Mallorca, which is quite more bigger. And yes, what we want to do here is to offer kind of modular technology systems that can be replicated in much bigger scale scenarios, meaning that we have kind of monitoring and getting data from the medium voltage and low voltage grid, so that we can leverage the impact of these low scale scenarios on the for example, on the voltage or frequency controls that we want to deploy, so that we can manage these renewable or non-dispatchable loads coming, for example, from wind or solar power, and provide them in a flexible way, meaning that we can use the utility scale or behind the meter scale storage to provide this flexibility. But again, for example, we are dealing in La Graciosa with 100 kilowatts of peak power installed on PV systems and about 250 kilowatt hour of storage capacity. But again, we will deploy, or our plan is to scale this kind of configurations knowing that in a small scale scenarios, we have an impact on this low voltage grid, and we have to monitor how could, or at least thanks to AIT and other technological partners, to know exactly what would be the impact on a simulation basis on bigger scale scenarios. Okay, but knowing that we have the exact behavior of the grid, because we have the DSOs and the TSOs involved in our project, we can leverage upon bigger loads. Speaking of megawatts, that would be our intention, and see how would be the round trip efficiency of the different technologies. And again, as our colleagues were saying, leverage upon the CapEx and OpEx of these different technology solutions and see if they're actually feasible in terms of replication and escalation. Because as we all know, we always end up speaking of money, because that's what really counts on these kind of projects. And well, but we are planning on doing so, and at least that would be this first small scale scenario approach would lead us to a bigger scenario simulation. And in case we can replicate and go further, we plan on doing much bigger things on these smaller islands. Yeah.
Okay, thank you very much, Josep. I mean, what you said is really important. I mean, this replicability and this adoption of technology, because, I mean, just to give you an example, in Cyprus, I mean, there is an incentive now for people to buy electric vehicles, which even with the incentive is cheap, is more expensive than the conventional cars. And still, people in Cyprus are not really motivated to go towards electric vehicles because of many reasons. And the main is basically the charging stations and the convenience that the charging will bring to them. Even if the bigger distance, let's say in Cyprus, 150, 200 kilometers, even that creates different obstacles. So looking at it from a more holistic approach in bigger islands to actually explore the adaptability of the different technologies would be something really, really interesting. Thank you.
Yeah, sure. I totally agree. That depends on the actual energy system or topology of the grid on each island. So yeah, I mean, the deployment of different technologies quietly depends on what is the actual energy system and grid topology of each of those islands. So yes, I believe that there's still a lot of work to be done. And as you were saying, in terms of electrical vehicle, we need, for example, I'm speaking now and I'm living and work here in Barcelona. We are working towards a heavy deployment on several EV charging stations among all the city, which I believe will enhance and enhance all these electrical vehicle infrastructure deployment. But again, it's tough, it's hard, and it's a matter of also convincing us, as our colleagues were saying, Costas was saying, it's a matter of convincing people that this is actually feasible, that this is reliable, and in fact that they also need these incentives, because there needs to be a more competitive approach on the electrical vehicles again. But I believe that this is the future, and it will be happening. I mean, it's just a matter of the public administrations to invest all of their money or as much as they can on developing these infrastructures. But I'm sure it will happen sooner or later, but it will happen.
yeah. But just sorry, Chair, for the last comment. Sorry, but touching upon your last comment on the public administration, I mean, these organizations usually have conflicting interests and conflicting objectives. I mean, just an example. I mean, a charging station might make sense at some point for the Ministry of Transportation, but might not make sense from the Ministry of Energy. So, I mean, because of network congestion and so on and so forth. So this is a problem we're facing in Cyprus now for the design of, I mean, if we take the transportation system, for example, that can fit and can fulfill as much as possible the objectives of different stakeholders in the society. Okay, thank you. Thank you very much for the response, for the time.
Totally agree.
Shall I
Thank you.
comment also, Mattheos? Yeah, in Greece, let's say the regulatory framework groups the islands has three groups of islands: small islands, less than 3-4 megawatt peak, large islands, Rhodos and Crete. Okay, Crete is no more isolated system. It's islands with 200 megawatts and peak and higher, and all the other is in the middle. What I've seen from a research project is that solutions applied in small islands can be also applied to medium-sized islands with major modification. But for large islands like Crete, Rhodos, and Cyprus, I have the feeling you should look for solutions that are applied in the mainland. For large system, complicated solutions. The size of the islands allows such investments. And yeah, that's my opinion. It's something that is applied in an island with 1,000 citizens. It's not easy to apply it in Cyprus.
I mean, Cyprus is small, but it's still 1 million, about 1 million. So yeah, I mean, your point is very, very well targeted. Yes, thank you.
Okay. I also have another question for the panel people, and especially those projects that involve islands in Southern Europe and Northern. Can you list the main differences between this region? What are different challenges in Northern Islands and challenges in Mediterranean? Who wants to answer? Maybe Alessandra, who has a broader view. You are muted.
Yes, thank you. So maybe I could start. So from our experience, what we can observe is actually that in the North, islands are usually small, and they, at least here in Nezoi under our first call, they were requiring more assistance in the early stages of the project. So for example, in planning activities or in identifying the priorities to actually deploy the energy transition. So also the support we're providing is pretty different. Coming to the South, islands are bigger, at least those that we are supporting, of course. And yes, projects are more mature, so more ready for their implementation. So if so yes, this is my answer. Of course, it's based only on our experiences so far.
Local economy also changes the technical solutions. For example, in Greece, part of the economy is tourism, big share
Exactly.
of the.
Absolutely, yes, but this is true also in the north. What we are observing there is in particular that islands are small, so also the impact of tourists is maybe bigger, because islands with very, very low population are having a lot of tourists in some specific period of the years, and this is also impacting of the energy demand, of course, and this also causes some issues when dealing with the sizing of the plants, for example, because the production needs to be very high only in some specific period of the year, for example. But yes, this is common also, for example, in Greece.
Yeah, very common.
So,
okay, so other panelists, they want to express their opinion on this question from Aris?
Here, Diego.
Oh, okay, Diego, yes, please.
Yeah, it's a trivial, but let me say that one of the main differences that for highlands that are located north of Europe, one of the main objects is to connect the heating district with the power system, let me say. But that's a trivial. Instead, for the south, it's quite different because the air conditioning it's use an electric vector, so it's done, let me say, for integration. And for my point of view, for example, in P4 Island, we have Formentera, that it's in the south, have a hot summer, and Bornholm in the north. in Denmark, but it's close to Sweden. And so for Burnham, the main goal is the connection between the heating district and make it more profitable than in the present with this connection between wind farms and storage, and coupling the storage that you can have from boilers and the storage that you can have, for example, from batteries or from fuel cells. So this is one of the main difference from our point of view, from my point of view.
Thank you, Diego. Indeed, two different, very different climate regions. So that is explaining these differences. Yes. I have another questions for all the panelists because we heard from speaking related to synergy and the storage systems. You mentioned some of you mentioned the battery and the hydrogen fuel cell. And some of you also mentioned that sometimes the numbers doesn't turn favorable for those storage for several reasons. That with your experience and in your project, what do you think it will be the main, let's say, storage technology that will be employed in the short term and possibly in the medium and the long term? So do you see, for example, the lithium-ion battery technology as the winning, or you see also space for small, let's say, other technology like compressed air, flywheels, or small hydropower as well? So what do you think? And hydrogen, of course, because hydrogen, I mean, there are a lot of, let's say, project going on, but still probably the cost is a bit far away from the objective. So what is your opinion on this storage technology? Yes, Kostas, tell us.
Yes. Well, I was actually before joining the ETIP SNET event, I was in a previous webinar on hydrogen technologies and on a Green Highland project, which is actually implementing hydrogen storage in the Mallorca electrical system. So, as you said, maybe the cost is still high, but what we consider is that in the short term, we see that battery storage is the one that we expect more largely implemented, but combined with other technologies as seasonal storage, we expect that this can deliver more integrated solutions, especially for islands that are facing a significant seasonal demand. So we see there is a lot of interest. Actually, the Green Highland project is promoted and delivered by Enagas in Mallorca, and there is very strong incentives there, and also by the Ministry of Energy in Spain. So I think that battery storage combined with traditional other storage technologies, but also with hydrogen economy as boosted as an overall hydrogen economy, not just as a single technology. I think this is something to come in the next few years.
Yeah, probably that's. Thank you, Costa. Probably that is the main, let's say, advantage to use different technology to make the grid, even at the local level, resilient and the secure. Because, of course, as a main, let's say, commandment on this is try to make. To have a different technology, because you cannot depend only on just one. Otherwise, if something happens, then you are in trouble. Okay, so more view on this from other panelists. Okay, so maybe Aris, at this point, maybe we can. Okay, you are Joseph. Yes, tell us.
Yes, if I may jump in just quickly, we have performed, or we are on the stage of performing a benchmarking analysis on different technologies, battery storage technologies, and see, as I was saying, the different CapEx, OpEx, and other energy density and other technical values to assess a little bit which could be the most suitable energy storage option among the different energy services that we want to provide to the grid. As you were saying, flexibility, resilience, robust grids. That's what we're looking for, because conventional or traditional grids do already offer this within the dispatchable energy units. We think that in our case, at least, I'm speaking of the Catalan business unit of Veolia, we are very confident that the hydrogen technologies could improve quite significantly its costs, meaning that the electrolyzer technologies and fuel cell technologies can reduce their costs significantly. We're working towards that. In fact, we are deploying in this project and in other projects innovative small-scale scenarios of power to hydrogen technologies. We are looking for these, and we expect to lower the overcoming barrier, which is right now the capex of these technologies. And we also believe that, for example, the flow batteries can do expect to lower their cost significantly, meaning that the two main flow battery technologies, which is vanadium redox flow and zinc bromine flow technologies, had total installation costs in 2016 between 300 and 1700 kilowatt hour. And these costs are expected to lower up to 500, 600 kilowatt hour. So I believe that, and also increasing these round trip efficiencies, I believe that at least the hydrogen and the flow batteries could be a very good alternative for the future grids in both small scale and big scale scenarios. In big scale scenarios, for example, the hydrogen systems are already implemented and working and efficient, already being implemented in many grids. So yes, it's just a matter of keep on investing on this R&D on R&I projects to lower these costs and to industrialize the production so that we can lower these costs over the next few years.
Thank you, Joseph. Yes, indeed. That is the purpose also the ETIP SNET, to veiculate the funds to the appropriate R&I research and development effort in all over Europe. Okay, Aris, I think what do you think to make just a very fast round of the table, just 20 seconds for 30 seconds for each of the panelists to give just the final impression, final word, what are their dreams or something for their project, let's say, in few words. So let's start from Joseph, following the same order. So 20 seconds is even more difficult. Before you had 99, now it's 20. So.
Okay, yeah, just very briefly, I focused a lot of my interventions on the technical side. I believe that the financial side and the exploitation of these projects is essential. So from our side, we expect the REACT and other R&D projects to be profitable, to be viable, and we expect that the feasibility of these technology systems is demonstrated within our projects.
Okay, thank you, Joseph. So now Kostas.
Yes, can you please repeat the question?
No, just to resume in 20 seconds, to make it more difficult compared to the 99 seconds. So in 20 seconds, your last impression. So what is your last thought on this issues on island, on the topic? Yes, thank you.
Yes, well, I mean, the topic of the discussion is decarbonization. So I would like just to raise the thought to everyone's minds. I know that we very much, face segmentation as discussed earlier, and we think about energy. But energy is life for the economy of the islands, and we need to combine energy with all the other concerns when it comes to the local development for islands, and this will bring success to our projects going beyond research and demonstrators. This will actually bring the benefits that clean energy transition and decarbonization says, and what the directives say, and how the islands can be actually lighthouses for other areas in these terms. So let's think in a holistic way, going beyond energy, combining with the other carriers, and think about integration. Thank you.
Franco, you're muted.
Yeah. Okay. Yeah, still muted. So I think that I could express my impression on this session that we have about the decarbonized European island. And I want to conclude with a hope. I hope that in the next future, with this new mean that are citizen energy communities, the population of island, the citizen of islands, could achieve some better results also in terms of involvement on the investment and the on the energy life of an island, because will be really important that that the citizen of island will participate in an active way in this process. So that's all. Thank you. Franco, you are still muted. Sorry, we cannot.
Sure, I make a mess now with the mutes, with the micro. So Alessandra, your last words.
Yes, final remarks.
Final remarks.
Yes. Well, actually, our ambition is to have is to bring concrete supports to islands. So we will be more than happy to see our projects actually deployed, implemented on European islands. So we have the second call now running. So for hopefully we could have more projects, more initiatives to be supported by our facility, and hopefully many of them will be actually realized and find concrete implementation.
Great. Okay, thank you, Alessandra. At this point, I think we have 2 minutes delay. So, Aris, what do you think?
I think we can
have
move
to move.
to the last one.
Yes. So let me thank to you all, and also to the participants, to the audience, and thank you, and see you in the next session.
Okay.
Thank you very much.
Thank you very
Take
much.
care.
Thank you.
Thank you. And Aris,
I will
yes.
send you my notes by mail.
Okay, thank you. Thanks.
Thank you. Goodbye.
Thank you. Bye-bye. Bye.